Okay, number 17. We're going to go quickly through this. And the way that we're going to go quickly through this is because this problem, there is so much computation that you're going to be putting in your calculator. I'm going to have the numbers. I am not going to work through it as I would work through it. It took me about 10 minutes. What I want to do is talk about what is mean absolute deviation. The deviation, well, first to look at the word mean. When you have mean absolute deviation, I first need to find the mean of my data. Okay? So quickly, what I'm going to do, and you can kind of put this in slow motion, look at your data and what you did. But first I need to add up all the numbers that are in my data set, which are 10 numbers, okay? These types of problems are tedious. They are boring, but they are the first one that is going to be the easiest to cause a miscalculation because there's so many numbers, okay? So slow down when you do this. And this number particularly has so many decimals, and even Miss Kowalski was getting frustrated with it. So when I entered all these in, I ended up adding them to get 318 and 55/100ths. And when you find the mean, you always divide it by the number of numbers, the number of data that you have, which is divided by 10. So what I found out was my mean was 31 and 86/100ths. Okay? So what do I do with that mean? Well, funny you should ask. As you move down, remember, now I need to find the absolute deviation. And we know that absolute is to mean the positive or the distance from 0 on a number line. Okay, so when I found my mean, what I do, instead of subtracting my larger from my smaller, I get a negative number, then I change it and to see how far. Okay, all right, Miss K's version, you need to pick the bigger number. Pick the bigger number, bigger number, bigger number, bigger number. You get it? Then what are you going to do? You're going to find the difference. Okay? This is the absolute. It's always a positive number. It is the deviation, which means how far it is away from your actual mean. 36. Subtract your lower number. 31/86, you get 4 and 14/100ths. Pick the larger number, 31 and 86/100ths, and subtract 22 and 33/100ths, and all the way down. I'm not going to bore you. So you put in all these absolute deviations. You are going to add them up, okay, which gives you a total of 96 and 81/100ths. And then you are going to, oh, this is the part where you find the mean absolute deviation. So the final step is actually the MAD, okay? So remember, you first find the mean of your data. Your second step is to find the absolute deviation of your data from the mean, okay? Then your third step is to find everything, which is the mean absolute deviation. You take the average of your absolute deviation. That's it. Add them up, divided by your number of data, and if you put all these into your calculator, you will end up with the number 9 and 68/100ths. And if we look at our data, if we look at the answer choices, my apologies, which one does it match up closely? 9 and 68/100ths most likely represents this number right here. Okay? One thing that will frustrate you on mean absolute deviation is always putting it into the calculator, messing up. Remember, you do have, so for example, you have the ability to, my apologies, look back at a problem. You can toggle up on your screen and look and make sure maybe your answer choice didn't come out at the end. Go back and review your numbers. Okay, make sure that they were entered correctly. But look at what Ms. Kowalski did. Look at all this work that I showed. Okay? I cannot recommend, it is always going to be 3 columns. Your mean, write the mean again, and you find the deviation of those 2 numbers, and then you find the mean absolute deviation. 3 steps, that's it. See you on the next one.